All right. Hello, everybody. Hello, hello, hello. Once again. All right. Python Crash Course on page 77 of 500 and God knows how much. Okay. One day at a time. One day at a time. So, in the previous stream, we learned about conditional tests, if statements. We learned about, let's back up here. Yeah, if statements was the start of the chapter. Conditional test, checking for equality. Using double equal sign for checking for equality. If statements, not equal to, operator, multiple conditions, and we learned about we learned about in, and we learned about not in. And then we learned lastly about Boolean expressions, which basically are just kind of like a light switch, is how I explained it. On or off. Is it true or is it false? All right. Conditional test. We're on the try it yourself 5-1 here. All right, we're on a new chapter. Moving up. We have come a long way, I will say, even though it doesn't feel like it, but we have learned a lot. What's this new folder? Oh, no. Why is there a... Okay, let's go here. Chapter 5. Okay, and this guy, oh, let's go ahead and clear these up. Clear them out, clear them out. Okay. New file in chapter 5. Come on. Chapter 5. New file. Okay. No, new file. Gosh. Conditional test 5-1. Okay. Page 77, conditional tests. Write a series of conditional tests. Print a statement describing each test and your prediction for the result of each test. Your code should look something like this. Car equals, quote, Subaru. Print is car equal to, quote, Subaru. I predict true. Print car equal Subaru. Create at least 10 tests. Have at least 5 tests value true and 5 value false. Gosh. Dang, dude. Okay. Fruit equals apple. Print I think fruit apple is true because fruit does equal, quote, apple. Quote apple. True. Okay. Let's just copy these over. This is easy. I don't need to worry about this. Fruit. Pear is equal to pear. I think will be equal to pear. Is equal to pear. True, true. Oh. Game equals Twister. I think. True, true. False. Fruit does not equal Twister. Game. True, true, true. Clear. We want two more. We want sport. Basketball. Game. Another game. It's another game. It's a game. What's a game? Game. What's a game? Board game. It's easy to spell. Monopoly? No. Connect Four? No. Wall ball. Wall ball. That's a sport. Wall ball's a sport. Game. Tag. Drew. See. Maybe. Oh, no. Fruit, apple. I think fruit, pear. Equal. False. Pear. I think fruit. Not pear. Orange. Orange. I think fruit. Nut. Watermelon. And C. And B. Fruit. Leave apple. I think let's change different fruits here. Kiwi. Last one. Fruit. Banana. False. Boom.
Welcome to VoiceOver. VoiceOver speaks to script.
No, I'm gonna do that. Alright, cool. Boom. Next up. Continued. Ah, crap. Keeps going. More conditional tests. I just did so many. Okay. New file. 5, 2 more. More conditional tests. You don't have to limit the number of tests you create to 10. If you want to try more comparisons, write more tests and add them to conditional test.py. Have at least one true and one false result for each of the following. Test for inequality and equality of a string. Okay. Name equals quote Michael. Name equals Michael. Name does not equal Michael. So this should give me true, false. Why? Oh, I didn't print anything. Gotta print it to the screen. Ding mod. Boom. True, false. Inequality of a string. Test using the dot lower method. Okay. Quote. That? Yeah, because I'm lowercase in the name here to lowercase m, and this is capital M. Like that. That can be true, because it is not equal to name dot lower. Boom. Numerical tests involving inequality and equality. Equality and equality greater than, less than, greater than, equal to, less than, equal to. Number equals 10. Right. Number equal to 10. So this should give me true. This should give me false. This should give me true. This should give me false. This should give me true. And this should give me true. True, false, true, false, true, true. I'm gonna do how do I get a new line here without? How do I get a new line without? It's like this. I don't really want to. I bet there's a better way. How do you print a new line at the beginning? Just quote \n or at the F string. I don't want a space. It's gonna give me one anyways. Why? I'll just concatenate. How can I get rid of the space here? How do I do this? How do I get rid of the space? Let's put a print statement. It's ugly as all can be, just sitting there, but true, false, true, false, true, true. Whatever. Moving on. Frustrating stuff. When you understand conditional tests, you can start writing if statements. Several different kinds of if statements exist, and your choice of which to use depends on the number of conditions you need to test. You saw several examples of if statements in the discussion about conditional tests, but now let's dig deeper into the topic. Alright, here we go. Simple if statements. The simplest kind of if statement has one test and one action. If conditional test, do something. You can put any conditional test in the first line and just about any action in the indented block following the test. If the conditional test evaluates to true, Python executes the code following the if statement. If the test evaluates to false, Python ignores the code following the if statement. Let's say we have a variable representing a person's age. We want to know if that person is old enough to vote. The following code tests whether the person can vote. Age equals 19. If age greater than or equals 18, print you are old enough to vote. Python checks to see whether the value of age is greater than or equal to 18. It is, so Python executes the printed indented call. You are old enough to vote. Indentation plays the same role in if statements as it did in for loops. All indented lines after an if statement will be executed if the test passes, and the entire block of indented lines will be ignored if the test does not pass. You can have as many lines of code as you want in the block following the if statement. Let's add another line of output if the person is old enough to vote, asking if the individual is registered to vote yet. The conditional test passes and both print calls are indented so both lines are printed. If the value of the age is less than 18, this program would produce no output. Okay. If else statements. Often you want to take one action when a conditional test passes and a different action in all other cases. Python's if else syntax makes this possible. An if else block is similar to a simple if statement, but the else statement allows you to define an action or set of actions that are executed when the conditional test fails. We'll display the same message we had previously if the person is old enough to vote, but this time we'll add a message for anyone who is not old enough to vote. Age equals 17. If age is greater than or equal to 18, print you are old enough to vote, print you have registered to vote. Else, print sorry, you're too young to vote, praise registered to vote as soon as you turn 18. If the conditional test 1 passes, the first block of the indented print call is executed. If the test evaluates to false, the else block 2 is executed because age is less than 18 at this time. The conditional test fails and the code in the else block is executed. Sorry, you are too young. Please register to vote when you're 18. This code works because it only has two possible situations to evaluate. A person is either old enough to vote or not old enough to vote. The structure works well in situations where you want Python to always execute one of two possible actions. In a simple if-else chain like this, one of the two actions will always be executed. The if-else chain. Often you'll need to test more than two possible situations, and to evaluate these, you can use Python's if-else syntax. Python executes only one block if and else block in an if-else chain. Python executes only one block in an if-else chain. It runs each conditional test in order until one passes. When a test passes, the code following that test is executed and Python skips the rest of the tests. So if that doesn't pass, try this other one. If this doesn't pass, try this other one. If this doesn't pass, try this one. Well, if those don't pass, I'll do this. Gotcha. When a test passes, the following code that the test is executed, and the code following that test is executed, and Python skips the rest of the tests. Many real-world situations involve more than two possible conditions. For example, consider an amusement park that changes different rates for different age groups. I can't read today. It charges different rates for different age groups. Admission for anyone under age 4 is free. Admission for anyone between ages of 4 and 18 is $25. Admission for anyone age 18 or older is $40. How can we use an if statement to determine a person's admission rate? The following code tests for the age group of a person and then prints the admission price. So age equals 12, says what the person entered, 12. If age is less than 4, print your admission cost is 0. If age is less than 18, print your admission cost is $25. Else, print your admission cost is $40. The if test 1 checks whether a person is under 4 years old. When the test passes, an appropriate message is printed and Python skips the rest of the test. The elif line is really another if test, which runs only if the previous test failed. At this point in the chain, we know the person is at least 4 years old because the first test failed. If the person is under 18, an appropriate message is printed and Python skips the else block. If both the if statements, if and elif tests fail, Python runs the code in the else block. Okay, cool. In this example, the if test 1 evaluates to false, so its code block is not executed. However, the elif test, because he's 12, he's under 18 but older than 4, so it's the middle test is going to pass. However, the elif test evaluates to true, 12 is less than 18, so its code is executed. The output is one sentence informing the user the emission cost. Your emission cost is $25. Any age greater than 17 would cause the first two tests to fail. In these situations, the else block would be executed and the emission price would be $40. Rather than printing the emission price within the if else block, it would be more concise to set just the price inside. Rather than printing the emission price within the if else block, it would be more concise to just set the price inside the if else chain. Okay, so instead of printing inside, he just sets the price, and then he wants you to print price using a string to save that. So then you can go ahead and change those prices at any point rather than changing the print. The indented lines set the value of price according to the person's age, as in the previous example. After the price is set by the if else chain, a separate unindented print call uses this value to display a message reporting the person's admission price. This code produces the same output as the previous example, but the purpose of the if else chain is narrower. Instead of determining a price and displaying a message, it simply determines the admission price. In addition to being more efficient, this revised code is easier to modify than the original approach. To change the text of the output message, you would need to change only one print call rather than 3 separate print calls. Using multiple elif blocks. You can use as many elif blocks in your code as you like. For example, if the amusement park were to implement a discount for seniors, you can add one more conditional test to the code to determine whether someone qualifies for the senior discount. Let's say that anyone 65 or older pays half at regular admission, or $20. Age. Okay, so they add another elif statement below the first one, where elif age is less than 65, price equals $40. Most of this code is unchanged. The second elif block now checks to make sure a person is less than age 65 before assigning them to full admission rate of $40. Notice that the value assigned in the else block needs to be changed to $20. Okay. Because at that point they're just an adult. No. It's the only age that makes this block over the people 65. Wait. Okay. So if per person's younger than 4, they set the price to 0. If the person is younger than 18 but older than 4, they set the price to 25. If the person is older than 18, older than 18, no. Yeah, older than 18 but younger than 65, the price is 40. So normal adults is 40. So 18 and older is 40. Yeah, I got you. Okay. Because the only age that makes this blocker for the people 65 or older. Python does not require an else block at the end of an if-elif chain. Sometimes an else block is useful, other times it's cleaner to use an additional elif statement that catches the specific condition of interest. Elif age greater than or equal to 65, print price is 20. The final elif block assigns a price of $20 when the person is 65 or older, which is a little cleaner than the original else block. With this change, every block of code must pass a specific test in order to be executed. The else block is a catch-all statement. It matches any condition that wasn't matched by a specific if or elif test, and that can sometimes include invalid or malicious data. If you have a specific final condition you're testing for, consider using a final elif block and omit the else block. As a result, you'll be more confident that your code will run only under the correct conditions. It's true. So if you have an else, by default, anything that doesn't pass your if elif statements will get sent to the else block. So even if it's wrong or not wanted, it'll go to that. So you can just use an elif statement to do the same thing, but pretty much close, and to make it so you have to pass a test to move forward. Okay. Testing multiple conditions. The if elif else chain is powerful, but it's only appropriate to use when you just need one test to pass. As soon as Python finds one test that passes, it skips the rest of the test. This behavior is beneficial because it's efficient and allows you to test for one specific condition. However, sometimes it's important to check all conditions of interest. In this case, you should use a series of simple if statements with no elif or else blocks. This technique makes sense when more than one condition could be true, and you want to act on every condition that is true. Let's consider the pizzeria example. If someone requests a 2-topping pizza, you'll need to be sure to include both toppings on their pizza. Requested toppings equals mushrooms and cheese. If mushrooms in requested toppings, print add mushrooms. If pepperoni in requested toppings, print add pepperoni. Adding pepperoni. If extra cheese is requested toppings, print adding extra cheese. Okay, we start with a list containing the requested toppings. The first if statement checks to see whether the person requested mushrooms on their pizza. If so, a message is printed confirming that topping. The test for pepperoni 1 is another simple if statement, not an elif statement or else statement. So this test is run regardless of whether the previous test passed or not. The last if statement checks to whether extra cheese was requested, regardless of the results from the first 2 tests. These 3 independent tests are executed every time this program is run, because every condition in this example is evaluated. Both mushrooms and extra cheese are added to the pizza. Okay, so if we want to do it at condition, we have to do if. If it's if, but then it can be something else, it's elif. This code would not work properly if we used an if elif else block, because the code would stop running only after one test passes. Here's what that would look like. Okay, so you just converted that print. The test for mushrooms in the first test to pass, so in mushrooms, the test for quote mushrooms is the first test to pass, so mushrooms are added to the pizza. However, the value extra cheese and pepperoni are never checked because Python doesn't run any test beyond the first test that passed. In an if elif else chain, the customer's first toppings will be added, but all other toppings will be missed. In summary, you only want one block of code to run. If you only want one block of code to run, use an if elif else chain. Oh my gosh, I cannot read today, people. This is bad. Long day at work. In summary, if you want one block of code to run, use an if else chain. If more than one block of code needs to run, use a series of independent if statements. Man, this chapter has a lot of tongue twisters in it with this if statement stuff. It's fairly simple though. Oh boy. All of page 84 is a try it yourself. Well, I've been going for 35 minutes. I'm going to take a little break there. Slide break, water break. Be back in 5 minutes. Get some water. with the tired stick, man. Sheesh. Oh. It's alright. I got this. Okay. Alien colors. Imagine an alien was just shot down in a game. Create a variable. Okay. We can do this. Keep moving here. Keep pushing. Keep pushing with me if you're there. Keep pushing. We got this. 5-3 dash alien colors 1. Imagine an alien was just shot down in a game. Create a variable called alien color and assign it to a value green, yellow, or red. Oh, I don't know. Okay. Write an if statement to test whether the alien color is green. If it is, print a message that the player just earned 5 points. Okay. If alien color is equal to green, print you earn 5 points. Okay. Write one version of this program that passes the if test and another version that fails. The version that fails will have no output. Okay. This is the passing one. Alien color equals, quote, red. Okay, we should get something and no output. Nice. You earn 5 points because this one did not pass. Cool. Next file 5-4 alien colors 2 .py. Gotta remember that. Okay. Choose a color for an alien as you did in exercise 5-3 and write an if else chain. Okay. Alien color is equal to green. If alien color is equal to green, print you earned 5 points. Okay. Else print not green. Hold it. Five points. Oh. Write an if else chain. If the alien color is green, print it. If the alien color isn't green, 10 points. Okay. Well, it's me to do the same thing. Make 2 instances. Boom. Cool. If I have 5. Okay. Turn your if else chain into an if else chain. Okay. So let's copy this. If elif alien color equal to yellow, print, you earn 10 points. Red, 15 points. Okay. Write 2 programs that work 2 rows at time. Write 3 programs, okay. So this should give me 5, 10, 15. Boom! Alright, 5, 6 stages of life. Write an if elif else chain that determines a person's stage of life. Set a value to the variable age and then, okay. Okay. Age equals 25. If age less than 2, print you are a baby. Elif age less than 4, print you are toddler. Elif age, let's call it, I'll call it back. Elif age less than 4 is toddler. At least 4 years old, but less than 13 is less than 13. Print quote, you are a kid. LFH less than 20. Print you are an adult. LFH greater than or equal to 65. Print So this is a little tricky because you might get tripped up on here. I think I figured it out though. So if I were to have the last bullet point, which is the 65 or older crowd, below this LF statement, well, a person that was older, greater than or equal to 65, would pass this LF statement, older than 20. If they were older than 20, they would not, and if they were 65, this would print, and they would not reach this message. So we need to put this one first as the top bounding parameter, and this one as the catch-all rest, because then all the rest will be adults. So if I put this at 25, I'm an adult. If I put this at 65, I'm an elder. If I put this at 3, I'm a baby. If I put this at 4, I'm a kid, right? At least 2 years old, but less than 4, a toddler. So I would put 2, this would be a toddler. Boom. Same with the kid. 0 up to 2 is baby. 2 up to 4 is toddler. 4 up to 13 is a kid. 13 up to 65 is an elder, or 65 and over is an elder. 13 to 20 is an adult. All right. Favorite. Okay. Cool. Next problem. 5-7. This is favorite fruit. Fruit. Ooh. Alright, so favorite fruit.py. Make a list of your favorite fruits and then write a series of independent if statements that check for certain fruits in your list. Okay. Make a list of your 3 favorite fruits and call it favorite fruits. Alright, I can do that. Equals to list, quote, apple. I love a good apple. I also love a good strawberry. And another fruit I like a lot is, I really enjoy good mango. A mango. A mango. Alright. Favorite fruits. Strawberry, mango. Alright. Write 5 if statements. Each should check whether a certain kind of fruit is in your list. If the fruit is in your list, the if block should print a statement such as, you really like bananas. Alright. If, quote, apple in favorite fruits, print. Oof. I could just go like this. I could be cheeky. For fruit, or for F in favorite fruits, if F in no, I don't know. If, quote, apple in favorite fruits, print, you really like apples. If straw can I represent these via variable somehow? Oh, yeah. 2, 3, 4, 5. If Nana Cool. Uh, Favorite fruit. Make a list of your favorite foods and write a series of independent statements that check your. Using if statements with lists. You can do something interesting. You can do some interesting work when you combine lists and if statements. You can watch for special values that need to be treated differently than other values in the list. You can efficiently manage changing conditions such as the availability of certain items in a restaurant throughout a shift. You can also begin to prove that your code works as expected it to in all possible situations. Okay. Checking for special items. This chapter began with a simple example that showed how to handle a special value like quote BMW when needed to be printed in a different format other than in the list. Now that you have a basic understanding of conditional tests and if statements, let's take a closer look at how you can watch for special values in a list and handle those values appropriately. Let's continue with the pizzeria example. The pizzeria displays a message whenever a topping is added to your pizza as it's being made. The code the code for this action can be written very efficiently by making a list of toppings the customer has requested and using a loop to announce each topping as has been added to the pizza. So he has requested toppings equals mushrooms, green peppers, extra cheese. For requested topping in requested toppings, so for every topping in the topping list, print adding that topping in an F statement. Print in a new line, finish making your pizza. Close quote. The output is straightforward because this code is just a simple for loop. Adding mushrooms, adding green peppers, adding extra cheese, finish making your pizza. Cool. But what if the pizzeria runs out of green peppers and an if statement inside the for loop handles this situation appropriately? Requested toppings equals mushrooms, green peppers, extra cheese. For requested toppings in requested toppings. If requested toppings equals green peppers, print, sorry, we are out of green peppers right now. Else print adding requested topping. Um, okay. This statement, we check each requested item before adding it to the pizza. If the if statement checks to see if the person requested green peppers. If so, we display a message informing them why they can't have green peppers. The else block ensures that all other toppings will be added to the pizza. The output shows that each requested topping is handled appropriately. Adding mushrooms, sorry, we're out of green peppers right now. Adding extra cheese, finish making your pizza. Checking that a list is not empty. We've made a simple assumption that about every list we've worked with so far. We've assumed that each list has at least one item in it. Soon we'll let users provide the information that's stored in lists, so we won't be able to assume that a list has any items in it each time a loop is run. In this situation, it's useful to check whether a list is empty before running a for loop. As an example, let's check whether the list of requested toppings is empty before building a pizza. If the list is empty, we'll prompt the user and make sure they want a plain pizza. If the list is not empty, we'll build the pizza just as we did in the previous examples. Requested toppings equals empty list. If requested toppings if requested toppings for if requested toppings, then do those code. Okay, else print are you sure you want a plain pizza? So if requested toppings, so if any in this list, if requested toppings, so if list, then yes. This time we start out with an empty list for requested toppings. Instead of jumping right into a for loop, we do a quick check first. When the name of a list is used in an if statement, Python returns true if the list contains at least one item. An empty list evaluates to false. If requested toppings passes the conditional test, we run the for loop we used in the previous example. If the conditional test fails, we print a message asking the customer if they really want a plain pizza with no toppings. The list is empty in this case, so the output asks the user if they really want a plain pizza. And if the list is not empty, the output will show each requested topping being added to the pizza using multiple lists. People will ask for just about anything, especially when it comes to pizza toppings. What if a customer actually wants French fries on their pizza? You can use lists and if statements to make sure your input makes sense before you act on it. Let's watch out for unusual toppings. I thought about this. So what if someone requests a topping that you don't have? So you have a list of toppings, then you have the user's list. So you say for pizza toppings in pizza toppings, if pizza topping in toppings, then proceed. Let's watch out for unusual topping requests before we build a pizza. The following example defines two lists. The first is a list of available toppings at the pizzeria, and the second is the list of toppings that the user has requested. This time, each item in requested toppings is checked against the list of available toppings before it's added to the pizza. Available toppings equals mushrooms, olives, green peppers, pepperoni, pineapple, extra cheese. Requested toppings equals mushrooms, french fries, extra cheese. For requested toppings in requested toppings. Okay, so we gotta get this right. For requested topping in requested toppings. If requested topping in available toppings, print adding requested topping. Else, print sorry, we don't have requested topping. Else, then finish making pizza. First, we define a list of available toppings in the pizzeria. Note that this could be a tuple if the pizzeria was a stable selection of toppings. Then we make a list of toppings that a customer has requested. There's an unusual request for a topping in this example, French fries. Next, we loop through this list of requested toppings. Inside the loop, we check to see if each requested topping is actually in the list of available toppings. If it is, we add that topping to the pizza. If the requested topping is not in the list of available toppings, the else block will run. The else block prints a message telling the user which toppings are unavailable. This code syntax produces clean, informative output. Adding mushrooms, sorry we don't have french fries, adding extra cheese, finished making your pizza. In just a few lines of code, we've managed a real world situation pretty effectively. Try it yourself. Oh, I'm so close to being done with the chapter, but I won't be done. Okay, I got 10 minutes left in me here. I got till 9 o'clock. We'll go until 9 o'clock. Alright, we will do new file 5-8. Hello, admin. Make a list of 5 or more usernames, including the name admin. Imagine you are writing code that will print a greeting to each user after they log into a website. Loop through the list and print a greeting to each user. Okay, pretty easy. Users equals admin, Michael, John, Matt, James. Cool. Loop through the list. Otherwise, if the username, okay. If, okay, for user in users if user equals quote admin, print hello admin, hello hello user, would you like a status report? Even though it's gonna be admin, I'm just gonna do that just to be safe. Else oh, got to give these quotes. Come on. Rookie mistake. Rookie mistake. Alright, there we go. Boom. Hello, admin. Would you like to search for boom, 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 boom. Boom. Otherwise, thank you for voting. Oh my god. Okay, cool. 5-9. No users. Add an if test to hello admin.py to make sure the list of users is not empty. Okay. If user so we need to find some. So if there's users, do this loop. Else, nothing. Uh-huh. I'm good. Okay. Next. Next code. Next line of code. Cool. What time is it? 5, 8, 56. Okay. 5 dash 10 checking. Okay. Do the following to create a program that simulates how websites ensure that everyone has a unique username. Make a list of 5 or more usernames called current users. Make a list of 5 usernames called new users. Make sure 1 and 2 usernames are also in current user list. Loop through new user lists. Alright, actually, I think this is what I'm going to call it on this one. I did about an hour and 15, hour and 13, hour and 15. We'll round up. We round up right. We're like the bank. We round up. Thanks to the one person that stopped in today. Appreciate it. Anyways, this is about just keeping holding myself accountable and making sure I do this because it's something I want to do. And I'm a quit. I'm known to be a quitter, so I don't want to quit on stuff. And I want to get this done. Do it well. I want to know this stuff well. So.